Well, in exponentials, the parent function kind of adjusts depending on what the b value is. So in an exponential, it's important to know that your parent function, it's hard for me to highlight that there it is. Your parent function is only the 4 to the x part. So that is going to be your parent function, just that 4 to the x. Now, the nice thing about Desmos is it gives you a nice, clean picture of that graph. So if you hit 4, and then just like delta math, you hit shift 6, and then put x up in your numerator, up in your exponent, there's going to be our graph of 4 to the x power. And it doesn't matter if you want to put y equals, that's fine as well. And we want to know, how does the function that's given in our notes compare to that? So we'll put a -1/5 out in front, and we'll start to look at what that does to our graph. So we'll hit y equals -1/5. Get out of there. We'll put times 4. Which would be times, oops, wrong one there. Hit times 4, and then we'll raise that to the x power. And just looking at how does that compare to my original. There we go. So if we look here, so that a value, -1/5, is going to start to transform our function. So y equals 4 to the x is our parent function. And we can see that it's got an asymptote at y equals 0. So it's just, it's approaching that x-axis, but it's not touching it. But then it increases as time goes on. Well, this negative out in front, that's going to start to flip our graph. So we can see that it's flipped over the x-axis. And then 1/5 is also going to compress our graph. Now, where have we seen that before? Well, we've seen it in every single function that we've been talking about so far. Now, some other things that you'll see, like if I put a plus k, so maybe I put plus k there, we'll add a slider. As I increase k, so here's where k is 0 right here. As I increase k, my graph is going up, which is what we've seen in the past. As I decrease k, my graph is going to start sliding down. So just like before, that h and k are going to start to move my graph up and down. You could also put a -h up with your exponent there. It's not letting me. I suppose I got to put that in parentheses. So we'll do that, parentheses, and then -h. And same as before, as h is positive, that's moving us to the right. So anytime I have x -6, x -7, that's going to move me 6, 7 units to the right. Anytime I have a plus k, so remember it's kind of opposite when we're dealing with the k, it's going to start moving me to the left. So we can see those same type of ideas coming into play that we've had in our functions that we've been dealing with in the past. So there would be a h value of 4, which would move me 4 to the right, k value of -1, which is going to move me 1 down. Now, one thing that we're going to start to see with exponentials, and we continue to see it when we start looking at rational expressions, is called an asymptote. So asymptotes are lines that functions approach, but they never touch. So here we have this line that the graph is coming up to, but it's never touching it, and it's just going to go run right along the edge of it. And that asymptote is y equals -1. And you'll notice it's always going to be the exact same as whatever your k is. So your k is always going to represent what that asymptote is, where your graph is going to approach but never touch. So that's going to be a new word. If you've looked at the notes, you heard that word. But if you haven't seen it, that's going to be a new word that we're going to start introducing called an asymptote. So if we head to Delta Math, I just want to show you an example of those 2 new problems I added. Okay, so here we have 5 to the x -8. And when we're graphing these, we are only going to graph 2 of them, 2 points. So here are the points right here. You can kind of move them around once you identify where your asymptote is, so on and so forth, and then the graph will start to produce here in just a second. But I would encourage you to head over to Desmos And you can put that function in and start to see where that function is, what its asymptote is, and find a couple of points that you can use to graph it out. So I have a horrible short-term memory. I already forgot what it was. It's 5 to the x minus 8. So we'll hit 5, shift 6, 5 to the x minus 8. And there it would be. And if you can't see it, you can zoom out or you can kind of scroll down. So 5 to the x minus 8 would be this black exponential here. Now you'll see your your k coordinate, that minus 8, that's going to represent that asymptote. So here's your asymptote coming down here. And exponentials are going to have horizontal asymptotes. So on delta math, I'm first going to select, it's going to have a horizontal asymptote at -8. So I'll slide that up. There's where my asymptote is. Then go back to Desmos. You just need to find 2 points where you kind of know a whole number x and y coordinates. So here I'm seeing it's crossing right at 0 and -7. And then here, if I go back to here, let's see. No, that's not working. So let's find another one that's got whole number coordinates. Looks like right here. We've got 1, -3. I can't get it to be exact. But there it is, 1, -3. So we'll plot those 2 points, 1, -3, and then 0, -7. So we'll go 0, -7, which is right there, and then 1, -3, which is right there. So once you slide those yellow dots, you will have your yellow dots will kind of lock in on whole number coordinates there. So everything checks out. So going back to Desmos, we've got our y equals -8, excuse me. We've got our y equals -8 asymptote, and then we've got a couple of points that we can graph out. So it's just getting a feel for making that connection between the k and the asymptote, and then finding a couple of coordinates to graph those out. And hopefully that'll check out. And it should, those, like I said, they kind of lock into the coordinates. So if you just get it close to where that coordinate is, those yellow will just kind of lock into those. So there's an example of those 2 additional problems. And I know there's about 5 of you who already completed 7-2. You can go back, check those out. The last thing I wanted to talk about is our graphing calculator. So as we get to the second part of our notes, we start using the value is called the natural number e. And e is an irrational number. It's irrational like how pi is. And it is used in a lot of financial calculations, but it's also used in a lot of different formulas and things that are used in science and math. So it is a important piece of information that we'll be using in math class, but then also in your other classes as well. So the natural base, e, of exponential functions. So you're going to be asked to find out a couple of values, 2e to the 6, things like that. And then also looking at continuously compounded interest. And both of those are going to require us to use the e button. So e, so if we head down on our calculator, if you go down to where the number 4 is, right to the left of it, you should see the ln. And some calculators have it capitalized ln, some are lowercase, doesn't matter, that's still ln. That's called your natural log. The e is the button right next to it, is the second function. So if we want to do 2e to the 6, I'm going to hit 2, second, ln, and then it's going to automatically raise it up to a power, because a lot of times e is used in the form of a power. So 2e to the 6, I would hit enter, and then there's going to be my result. So that is how we can use that e button. So you'll use that e button when you are using the continuously compounded interest, and then also when you're using just to find values of e, you'll be using that button as well. The last thing is, and I'm not going to review the whole process, but we've got an example in our notes from an exponential growth. So here we have number of roaches, and then as time goes on, they're going to grow exponentially. That's because each female roach can have babies, and they have multiple babies, and it starts to create an exponential growth. And then those babies have babies, and it starts to grow exponentially. So it's a exponential type growth. You could also think of what's going on, how the virus is spreading exponentially. So as one person gets it, they can spread it to 5, 10 people, and then those 10 people spread it to 5, 10 people. It starts to grow pretty fast. Well, we can find an exponential equation in our stat area. So if you hit stat, back in first semester, we used stat edit, and you can put in your data into L1 and L2. But when we get into exponential, I just want to show you when you're calculating exponential is EXP, and you have to go down a little bit. It's going to be number 0 down there. So exponential regression. So you can use that to find an equation. Once you get your data in, you get your number of days, you put your number of roaches in for L2, you can hit exponential regression, and that's going to give you then a calculation, and it'll give you your equation in y equals ABX form, just like we've been working with. So your graphing calculator is an important tool that we're going to use with the E button and with the regression lines. And then also, I encourage you to use Desmos. And if you're looking for how to get to Desmos, I'll always have that link right on our schedule there. So that'll be a couple of important things that we can use. So just one more reminder, I did add 2 additional problems. So like I said, there's about 5 of you who completed the assignment. So I just would like you to go back, try those 2 additional ones, see how you do.